Let's run through a few examples. Example 1, find the integral of 4x plus 1 all to the power of 5. Now the trick or shortcut here is that you're going to want to integrate the main function as normal and then make some adjustments. So what I mean by that is, if we look here, we've got 4x plus 1 all to the power of 5, something to the power of 5. When you integrate that, you would raise the power by 1, so make it to the power of 6, and then divide by the new power, or times by 1 over 6. What's inside the bracket stays the same. And then the adjustment that we need to make is that we actually need to divide by the derivative of what's inside the bracket. So in this case, the derivative of 4x plus 1 is 4. When you differentiate 4x plus 1, you get 4. So we're going to want to divide by 4, or another way of thinking about that is timesing by a quarter. And then because we're integrating, we need to have plus c, and that is the answer, but then we can tidy it up to make it look neater. So that would be 1 over 24, 4x plus 1 to the power of 6 plus c. Now, the reason this works is because we're effectively doing the opposite or reverse of the chain rule for differentiation. We can actually check our answer by doing the chain rule for differentiation. So let's say you had time at the end of the exam and you wanted to check your answer. If you set y equal to 1 over 24, 4x plus 1 to the power of 6, and then you think about how you would differentiate that, let's use the chain rule and make it y equals 1 over 24 u to the power of 6, where u equals 4x plus 1. dy du would be 6 over 24 u to the power of 5, so bringing the power down and reducing the power by 1. And then du dx is just 4. Chain rule then says we multiply those two together to get dy dx. So it'll be 6 over 24 u to the power of 5 times 4, which is 24 over 24 u to the power of 5, or just u to the power of 5. We know that u is 4x plus 1, so that shows that we arrive back at the original expression. Example 2, find the integral of cos 3x plus 1. Now, when you integrate cos, you get sine. So we'll write sine 3x plus 1. And then the adjustment that we need to make here is that we need to divide by the derivative of what's inside the bracket again. So the derivative of 3x plus 1 is just 3. So we need to stick a 1 over 3 on the outside and then plus c. So we're dividing by 3 because the derivative of 3x plus 1 is just 3. Example 3, find the integral of 2 over 5x plus 1 squared. Before we try to integrate this, let's rewrite it. So 2 brackets 5x plus 1 to the power of minus 2. Easier to see what's going on now. So when we integrate this, we'll raise the power of the bracket by 1. So make it to the power of minus 1. Divide by the new power, which is a minus. Keep the 2 on the outside as well. And then finally do the adjustment, so divide by 5 or times by a fifth, because that's the derivative of 5x plus 1. And then that's the answer with a plus c on the end. Tidying up gives minus 2/5 brackets 5x plus 1 to the power of minus 1 plus c. Last example, find the integral of e to the power of 3x plus 4. Now, when we integrate e, it stays the same. So we'll have e to the 3x plus 4. But then our adjustment is going to be dividing by the derivative of 3x plus 4, which would be 3. So we'll put a third on the outside there. And not forgetting the plus c, of course. And that's it. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.